Good morning, guys, or good afternoon if it's after lunch. I am out today, so I'm going to record this lesson. Here's your warm-up. Go ahead and get started. Thank you very much for logging in and opening this up so we could all see it. You can go ahead and pause it now, and then go ahead and resume play when you guys are done with the warm-up. Obviously, I'm not here to answer questions. If you guys want to kind of ask around your area, that's totally fine with me as long as it's okay with the sub. Okay, we're going to go ahead and start adding and subtracting rational expressions. Kind of a continuation off 9.4, still very easy. So what we're going to do is we are going to factor down completely. I'm going to go ahead and factor down this denominator over here on this side. All right, so here's what you do when you go to add this stuff. It's just like when you add common denominators on regular fractions, guys. You got to make the denominator the same. As you notice, both of these fractions have a 3. Both of them have an x plus 5. And all we need to do is change this one right here to one that has a denominator of also x plus 2. So just like you do when you do common denominators, you multiply by what's missing. So we're going to multiply just this fraction over here of x plus 2 over x plus 2. So once we get to this part, we're going to just combine the numerators. This is the first fraction. The second fraction, after we get a common denominator of 3 times x plus 5 times x plus 2, remember this top part is being multiplied by x plus 2 also. So this is 4x squared plus 8x. Now you can combine like terms in the numerator. So your brand new numerator is going to be 4x squared plus 8x plus 1. And your denominator, your common denominator, remains unchanged. Guys, from here, go ahead and check to see if your numerator is factorable or not. This is not factorable. There's not any properties that add up to an 8 that multiply together to make a 4. So this is going to be our final answer. And usually, when you add and subtract rational expressions, you do not need to state restrictions. On a test or a quiz, which you guys have a quiz coming up on Friday, if you have that situation, I will be very specific if I want restrictions stated or not. On this, I do not need restrictions stated, so I'm just going to box in my final answer. That's it. All right, let's move on to the next example. Over here, we are subtracting. Don't forget to distribute the negative. Remember, the first thing we need to do is we need to factor down both of these expressions as far as we can take them to see what kind of common denominator we're needing. So this one, as you can see, they both have an x plus 1 in the denominator. Now, what is missing over here on the left side, it's missing a 4. So I have to multiply this fraction by a 4. So it's going to turn into this. On your other fraction, it's missing an x minus 3. So the fraction on the right turns into this. Go ahead and multiply those two fractions by what we are missing for the common denominator, and then we're going to go ahead and combine like terms in the numerator, and then remember we always check to see if anything is factorable. All right, as you can see, there's nothing that factors out here either, so let's go ahead and box it in. Okay, this one. Guys, remember, the 5 is a whole number. For the whole number, you just put it under 1. So all we really need to do is multiply this left fraction by x minus 2 on top and bottom. Left fraction, right fraction. Combine your numerators. All right, guys, go ahead and try this on your own. By the way, we do need to go ahead and pause now to give everybody a chance. So someone pause me. All right, guys, check your work. Hope you got it right. Moving on to the next slide. All right, guys, here we've got a complex fraction. Just like on Monday, you're going to break them up and use the division symbol that you used back in elementary school. All right, so what we're going to do is we're going to go ahead and combine this first expression right here. So this x needs a y. The y needs an x. What we're going to end up combining is a y plus an x, and that's over xy. Now let's focus on what used to be in the denominator. This needs an x. This needs a y. So when we combine this over here, we're going to get 2x minus y over yx. Remember that these are fractions, so we need to do leave, change, flip, guys. Leave. Change the division symbol to a multiplication symbol. Flip your other fraction. Uh-oh. Wrong, wrong, wrong. Look, just like when I'm in regular class, I'm making all these mistakes. And then cancel out, so your final answer is this.